So to answer question number 14 in this chapter, which is a sample of chromite weighing 1 gram is fused with Na2O2, bleached with water, acidified with H2SO4. The resulting solution is divided into 2 equal portions. One portion is treated with 50 ml of ferrous solution containing 39.22 grams of FeSO4 NH4 2SO4 6H2O per liter, and the excess requires 6 ml of K2Cr2O7 solution. What volume of thiosulfate would be required to titrate the I2 liberated from excess Ki by the dichromate in the other portion of the solution? And what is the percentage of Cr in the sample? So the first thing we do is to get the grams of the FeSO4 NH4 2SO4 6H2O by using this grams per liter of the FeSO4 and this 50 ml of the ferrous solution. So grams of FeSO4, 39 is equal to 39 grams, 39.22 grams per liter, multiplied by the 50 ml of the ferrous solution. And then to be able to cancel the units, we multiply this by 1 liter over 1000 milliliter. And this results to 1.961 grams of the FeSO4. Next is for the 50 ml. This is 50 ml. 50 ml. So we use the 1.961 grams we got earlier, and then we convert this into moles by multiplying it to its formula weight, which is 392.21 grams of the FeSO4 NH4 2SO4 6H2O. And on the numerator, we have 1 mole or 1000 millimole, resulting to 5 millimoles. So next is to get the concentration of the iron. We are given here the grams of the number of grams of the iron and the volume. So we use this to get the concentration. So 0.008378 grams multiplied by the formula weight of the iron, which is 55.85 grams. Let's make this millimoles. So this will be the same with what we got here. So all over the volume, which is 1 milliliter. So the result is 0.15 molar of iron. Next is to get the millimoles of the FeSO4. So to be able to get this, we use this one and the given number of ml or the volume. So the number of millimoles of FeSO4 is equal to the 5 millimoles minus the 6 ml multiplied by the molarity of the iron, which is 0.15 m, and this is equal to 4.1 millimole of FeSO4. So for the other 50 ml, For the other 50 ml, we are given the number of grams of copper and its volume, and we will use this to get the concentration of the thiosulfate itself. So the concentration of thiosulfate, which is S2O3, we use the 0.01271 grams multiplied by the formula weight of the copper, which is 63.55 grams. Let's make it millimoles again, all over the volume, which is 1 ml. And this is equal to 0.2 molars of the S2O3 or the thiosulfate. So the next step is to get the volume of the thiosulfate. So let X be the volume. So here we will get the millimoles of the Cr2O7 in terms of the millimoles we got of FeSO4 and the molarity of the S2O3 of the thiosulfate. So we will get the millimoles of Cr2O7. Let's first use the 4.1 millimoles of FeSO4. So 4.1 millimoles multiplied by 1 liter or 1 mole over 1000 millimole, to cancel this one, multiplied by the molar ratio of the iron and the Cr2O7. So 6 moles of iron, and above is 1 mole of Cr2O7. And this results to 6.835 times 10 raised to negative 4 moles, or 0.6835 millimoles. So next is to get the number of moles of the Cr2O7 still, with the use of the concentration of the thiosulfate we got earlier. So 0.2 molar, or let's use moles per liter here, of the S2O3 multiplied by the molar ratio of the thiosulfate to the I2, which is 2 moles of the thiosulfate, and above is 1 mole of the I2, multiplied again by the molar ratio of the Cr2O7 in the I2, so 1 mole of Cr2O7 over 3 moles of I2. So we multiply this by the volume, which is unknown, which we represented earlier as X. So let's multiply this by X, and we get 0.03333 molar times the X of the X, which is the volume of Cr2O7. So now we have 2 millimoles of Cr2O7, and we will equate this to be able to get the volume of the thiosulfate. So 0.0 0.03333 molar times the volume is equal to 0.6835 to 5 millimoles of the Cr2O7. So dividing both sides by 0.03333, we get the answer. We get the volume, the X, which is 20.51 ml. So we already answered the first question. So the second question is, what is the percentage of CR in the sample? So what we need to do is to convert the number of moles of the thiosulfate to the moles of chromite. So, and we will divide it by the given weight of the sample times 100. So the percent chromite is equal to the 0.2 molar of the thiosulfate times the volume we got, so 20.51 ml, and then multiplied by the molar ratio of the I2 and the thiosulfate, so 2 moles of the thiosulfate, and above is the 1 mole of I2, multiplied by the molar ratio of the Cr2O7 all over the moles of I2, and multiplied by the number of moles of Cr2O7 and the Cr, or the chromite, Cr, multiplied by the formula weight of the Cr, which is 52 grams all over the mole. So this is all over the number of the weight of the sample, and since we have 1 gram as the weight of the sample, and it is said that we divided this into 2 equal portions, so 1 gram divided by 2 is 0.5 grams, and multiplied by 100 to get the percentage times 100, and this results to 14.22%, and that is the final answer.